Uh, Thank you very much for joining our class. Today we are going to be looking at the final revision. So meaning that we're going to be discussing about some questions, and then I give you a highlight of what is expected to be in your exam you're gonna write. Uh, if you have any challenge or any question, let me know so that I can help you out. Let me start with some questions I've prepared you so that we can at least have a clear view of what you expect to find in the paper. I'm going to be dealing with all the sections so that everyone, or if you have any challenge on a specific part, then you are helped out. M.Sa, don't forget to subscribe, like, and also share for others so that they can also benefit. Let's start without wasting time. We have different questions here, and the first question is about organic. Don't forget that this paper, most of the marks are going to come from organic, meaning that we expect you to be passing this paper. And then the other parts you'll find if you do organic, it's a guarantee that you have passed. I'm talking about the minimum, the mark which doesn't take you to the university, less than 50. So when you have now you add these other sections, then you project your marks to a distinction. So let's focus for a distinction, not just a mere passing. All right, let's start with these questions. They're saying that letter A to D in the table below represents 4 organic compounds. So you have different organic compounds here. So the first question is going to be about this naming, identifying the type of functional group, homologous series, such things. So let's look at it. Letter represents a keton. Which letter is representing a keton? Don't forget that a keton, it has oxygen and 2 alkyl groups, meaning that this can be a carbon and this is a carbon and a carbon. You understand? Doesn't matter how long it is, but this functional group must be in the middle. So in this case, if you look at this, it's no. Check here. This is see the way it is there. You see that that's the functional group, and then it resembles this. So the answer becomes B. So when they ask you about the keton, I think you can differentiate it from the aldehyde and alcohols. Then we got the structure formula of the functional compound of group of compound C. When you look at compound C, they're saying the structure formula. Here is the key point. Don't just write. They're saying the structure formula. So what is the functional group of compound C? What is compound C? So compound C, it is what? The functional group of compound C. If you look at compound C, it is what? It is an aldehyde. So how do we write the functional group of the aldehyde? Sorry. So it's going to be C. Yes, it has an alkyl group with oxygen and then a hydrogen. So these are just the simple questions of which anyone can answer them. So I'm not going to waste too much time. I want to take more time when it comes to the chemical equilibrium, acids and bases, those questions which require more and more calculations. Then we go to the general formula of the homologous series. So look at this general formula. They are looking for the general formula of homologous series of A. Where is A? It is an alkyne. So alkynes, don't forget that you have CnH2n plus 2. That is alkane. CnH2n. When you leave it like that, then it becomes alkene. Then CnH2n minus 2, then it becomes an alkyne. So you start with the 2, then you don't talk about the 2, then you minus the 2. So basically, that's how you can remember that structure. So in this case, what are you going to say? You're going to say that, guys, if you have a question, let me know. Please don't keep quiet. If there is a question, I'll try to answer that question out. All right, let's go to, we are saying that, so it means that this becomes the answer for our question, this question which we are talking about, because it is an alkyne. So we're done with that. IPAC name of A. If you look at A, what are you going to label on A? Where is A? So look at this. You have, now let's label it. Sometimes naming it becomes a problem if you don't understand the criteria you're supposed to write. Basically, where is the problem coming from is to identify the functional groups. To identify not the functional group, the side groups. The side groups becomes a very big problem. So you have 1, 2. So this one is on number 2. Number 1, this is 2. The functional group is on carbon atom number 2. 1, 2, 3, 4. The functional group is on carbon atom number 4 if you use this direction. I think now we can find out. All right, now let's count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I think. So it means that this one has the longest chain comes like this. You see? 1, 2, 3, 4, 5. It means that now this one is on 5. 1, 2, 3, 4, 5, 6, 7. 1, 2. So I'm gonna go with the shortest one. So meaning that if I go with this as the longest chain, so it means that this and this are going to be the side groups. So now let's label it, or let's try to name it, and then we find out. So guys, you should not have a challenge with this. So now let's count. 1, 2, 3, 4, 5, 6, 7. 7 is helped, né? But is the functional group is on carbon atom number what? 1, 2 is on carbon atom number 2 dash 2, and then you say because it is an alkyne, so I'm gonna add Y and E, so it is heptene. So however much if you lose this, what is before here, but you have mentioned this correctly, at least we shall give you a mark. Try and do what you think, where you can get marks, because when you are answering this, we don't answer this all of it, like all of it, then you get all the marks once. You get all the marks once. No, we give you marks depending on what you have answered. So you must not panic because you have lost the longest chain. No. So okay, let's continue now. So if this is heptene, then let's look at now the side groups. So because you have used this direction, guys, don't change the direction. No, you continue with that direction you have used. So now you're gonna be 1, 2, 3, 4. This one is on carbon atom number 4, but it is a what? Which side group is this? It's 1, 2. So it is ethyl, because the side group is eth. So I add YL to show that is a side group. But it's on which carbon atom? 1, 2, 3, 4. So it's on carbon atom number 4. So it's going to become 4-ethyl. Then I continue saying that 1, 2, 3, 4, 5. This one is on carbon atom number 5. So it's going to be 5. How many carbon atom is 1? So it's going to be meth. Because it is a side group, I'm going to add YL. So it becomes methyl. So now I've got to know the naming of the side group, the naming of another side group, and the main chain. Now I have to combine all of them. How do I combine them? How do I combine them? I have to look at this, and I look for which one is first in the alphabetical order. I don't change the numbers. I only start writing with the one which starts in the alphabetical order. So now if I have this E and M, I will find out that is E which is first. Therefore, I'm going to say it's 4 dash ethyl, yes, dash 5 now, dash methyl, yes, you see, now heptene. That's how we label, or how we name this. How do we name it using the IPAC naming system? So I think I'm clear there. Unless you have a question concerning about it, let me know if you have any question concerning about that. Now let's go to the next question, and then we see. The next question is saying that IPAC name of B. What is the IPAC name of B? B is a keton. So since it is a keton, it is simple to write. It must end with on. So it is 1, 2, 3, 4. So it's gonna be 4 is but. You understand? So but 10, and then what is the functional group? Where is it found? Is carbon atom number 1, 2. So it's gonna be but 2 on. Listen carefully. There is something small which makes students fail when it comes to this. Listen carefully, and let me give it to you. What makes students fail? Okay. When it comes to alkene, yes, alkene, alkene, and alkynes, yes, you say but, prop, then you put whatever you want to put. Ne? But when it comes to alcohols and other homologous series, you don't stop here. For example, this is but2, maybe yin, whatever. Ne? But now when it comes to alcohol, you say butane. You add this until here, then you say 2 or something like that. It is supposed to go up to this point. But if you're talking about alkene, alkene, and alkynes, you only stop on but. And when you're talking about the side group, you only stop on but. Like you don't go to butane. You understand? So please, also that one makes students to fail. Let's go to question 4.5. Question 4.5. So I think we are done. So it's gonna be but2 on. And then compound D is a gas used in cigarette lighters. You understand? Compound D. Then they're saying that which homologous series does compound D belong? So compound D, let's look at compound D. Where is compound D? Is butane. So to which homologous series does it belong? It belongs to, the moment you say butane, N, it is an alkane, because it is derived from there. It's an alkane. So the homologous series is alkane. So they are saying that write down the structure formula and IPAC name. The structure formula and the IPAC name of what? The IPAC name of structure isomer of compound D. Structure isomer of compound D. What does it mean? Okay, they're saying that write down the structure formula and IPAC name of compound D. Someone is asking. All right. They're saying that, to which homologous, okay, IPAC name, write, the compound D is, okay, we are done with that. Write down the structure formula and IPAC name of structure isomer of compound D. So what are you going to write? Where is compound D? Compound D is butane. You understand? But they want the structure, write down the structure formula. They want the structure formula and the IPAC name of that compound D. So what are you going to write here? So compound D is butane. Let's look at butane. It's 1, 2, 3, 4. So it's a butane. So butane is like this. Okay, it's like that. So I'm going to bring about the what? I'm going to bring about the isomer. So what I'm going to bring about, I'm going to bring this and I put it there. So it's going to become 1, 2, 3, 3, because it's 1, 2, 3, and then I can put it down or up. It's the same thing. Make sure that everything is put 4 hydrogens. It must be hydrogen. Don't leave them hanging. It must be, all of them must be hydrogen, hydrogen, hydrogen. Cool. Yeah. So now it has become an isomer of this. So now I have to label it. So what am I going to label? It's 1, 2. So this one is on carbon atom number 2. So it's going to be 2 methyl, because this is a side group. Methyl, methyl, and then 1, 2, 3, propane. That's it. That's what they want. So they will give a mark here, and they'll give a mark here, depending on what they have put the marks where exactly. Then let's go to the next question. They're saying that is isomer, you have mentioned above, positional, chain position, or functional. So what if you look at it, what has changed here? Is it a functional group? No, we don't have functional isomers in alkanes. Yes. So what you have changed here is the chain. You have changed the chain, the structure of the chain. Therefore, it's going to become chain isomer. It's going to become chain isomer. So the answer here is going to become chain isomer. Chain. Where am I? Chain. Here. It's going to become chain isomer. Compound D reacts with bromine. Compound D, the moment they say it reacts with bromine to form 2 bromo, butane. Yes. So what are you saying here? The type of reaction, okay? Then they're asking you, name the homologous series to which 2-bromo-butane belongs. So to which homologous series? The moment is bromo, that is an alkyl. Yes, an alkyl. You understand? Yes. No, not alkyl. It's a halide. And then butane is an alkyl, and then bromo is a halide. It's a group 7 element. So it can be alkyl halide. Yes? Or haloalkanes, because this is an alkane and then this is a halogen, so we call it haloalkanes. Or alkyl halides. Any of what you give, they will give you a mark in that regard. They're saying that the type of reaction that takes place, how do we call that type of reaction that takes place there? Because we have substituted hydrogen with bromine, then it's going to become substitution reaction. But which type of substitution is going to be halogenation? Which type of halogen, the actual halogen which is being substituted there, is bromination. Actually, you have added bromine in there. So basically, substitution is a big one. Halogenation is a little bit bigger or moderately. And then bromination is the actual. If it is chlorine, then it's going to become chlorination. If it is iodine, it's going to become iodation. So it depends on what you have substituted. But if you don't remember all that, just say halogenation, because still they will give you a mark in that regard. Before I go to the next question of this, so that's the first question, is about naming. Make sure that when you go to the paper, you are able to answer a question concerning about that. You understand? The next question which I can talk about here, where students might lose marks, is when they bring a question whereby they ask you for the reaction. I think I will speak about it when it comes to the reaction. whereby they react with bromine. And then this, the red color of bromine is what? Turns colorless. You understand? In actual sense, is decoloralized. Ne? It turns what? Colorless. Yes, as a result of passing through a specific compound. So when the bromine color turns into colorless, as a result of that reaction, it means that that compound had a double bond between carbon atoms, or it had a triple bond between carbon atoms. So alkanes, they will not decolorize. They will not change this bromine water, the red color, into colorless. Never. What will do that is either a triple bond or a double bond. A triple bond can be converted into a double bond, and then at the end of the day, you will have bromine attached on each. You understand? So you need to know that if they bring it in an experiment, you must know that the one which decolonizes must have a double bond, or it must have a triple bond. Okay, let's go to the next question without wasting time. The next question, they're saying that consider the organic molecule or organic compound represented in that diagram. They're saying that A to C below, what happens to A to C? They have given you different molecules. You understand? Yes. So in this case, you have to just a moment, guys. Okay. They're saying that name the homologous series to which C belong. To which C belong. Where is C? C is here. So it's the same example as the other one. It is to which homologous series does C belong? It belongs to the ketones. Check how it is. So it is a keton. Yes. And then they're saying that what is the IPAC name of A? You see, now it's the same question which they brought there. Now it's almost the same thing. So it seems that you won't be able to fail anything related to naming. So what are you supposed to do? First, find the identify. Let's just show you how you name it. The same way I named the other one. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you see, now the longest chain is 8. So is it a single bond? Single bond throughout. So it means that this is going to be a side group. Is it only that? We also have this and this. I think. So they are going to be side groups or the functional groups. Ne? So if I count from this side, 1, 2, 3, 4. This one, the first one is going to be on carbon atom number 4. The second one is going to be on carbon atom number 5. What about this? 1, 2, 3. The first one is going to be on carbon atom number 3. The second one is going to be on carbon atom number 4. So I'm going to go with the short one. So now it means that I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be octane. Yes, so it's going to be octane. So you get a mark for longest chain. So 1, 2, 3. So the first one is on carbon atom number 3. Which one is this? Is 3 chloro. Yes. The second one is on carbon atom. I've used that direction. So I have to continue. I have to keep that direction. 1, 2, 3, 4. You see? It's on carbon atom number 4. So now I'm going to say what is this? It is a methyl. So it's going to be 4-methyl. 1, 2, 3, 4, 5. It is on carbon atom number 5. What is it? Is a chloro. So it means that it's also another 5 chloro. You see? Now we're going to have to combine them. I have octane, and then I have 2 chloro. So I'm going to combine them, and I say 3,5 dichloro. You see? And then I have 4-methyl. But C and M, which one is first? It is C which is first. Therefore, I'm going to say what am I going to say? I'm going to say 3, comma, a figure, and the figure we separate with a dash. 3, comma 5, dash, di, chloro, then I add this, dash, 4, dash, methyl, octane. 3, comma 5 dichloro, 4 methyl octane. So that's how we basically supposed to name these organic molecules. Guys, I think it's not that difficult. Do you find any challenge? Someone is asking me that, do you have the memo for how 10 September paper 2? They are writing tomorrow. Why should you ask for the memo? I'll give you the memo tomorrow. When immediately after you are done. Then I'll go through the paper. Yes. Even if I give you the memo, does it mean that you're gonna get a memo on finals? So it means that you're just ruining your life. So guys, let's concentrate on this. Let's go through this, and then tomorrow when you come out of the paper, you come back and tell me a story. Yes, let's go through them, and then tomorrow when I'm going through the paper you're gonna write, tomorrow maybe around the 2 o'clock, or depending on the electricity, or 4 o'clock. Yes, I'll go through your paper, and then you see how you have. Even if you have not passed, still to help you to prepare for the finals. Yes, so don't stress. Let's continue, guys. Let's focus for the future so that we get distinctions. All right. And alcohol and the methanoic acid are heated in presence of concentrated sulfuric acid. The moment you bring about alcohol, and you bring about carboxylic acid, because when you say oic, that's a carboxylic acid. Sorry. The moment you talk about that, you are talking about esterification. It must come into your mind that you are talking about esterification. Okay. So what is esterification? Formation of esters. So it means that you form esters using alcohol and the ethanoic acid in the presence of heat and the concentrated sulfuric acid. Yes. So what is the role of concentrated sulfuric acid in this reaction? Guys, whenever they ask you, the role of concentrated sulfuric acid is acting as a catalyst. Catalyst. You must know that. Is acting as a what? A catalyst. They are saying that write down the name and the formula of the inorganic product formed. Definitely, it's going to be water, because the moment you have alcohol plus the carboxylic acid, you form in the presence of the sulfuric acid, and you heat, you're going to form an ester plus H2O, which is water. So it means that water is the inorganic molecule they're asking you to write about. And then when they ask you to write the structure formula, even water must be in form of a structure formula. In most cases, people don't write this water when they're asking you to write the structure formula, and you end up losing marks just like that. Okay, let's go to the next question. Okay, we have seen that the inorganic molecule here is going to be water. So they're saying that ester contains 6.7 hydrogen, and then 4 of carbon, 53 of oxygen, and then the molar mass of ester is 60 grams per mole. Use the calculation to determine its empirical formula, and then later you talk about the molecular formula. How do we do this? It's a simple thing to do and to get. So what you do need to do is to find out the elements which are given in this reaction, and then you are able to get. Okay, the first one is hydrogen, carbon, and oxygen. Carbon, hydrogen, and oxygen. And then you need to know the mass of each they have given you. Carbon, they say that the percentage they have given it in terms of, this is 53.3, and then this is 40, and then this is 6 is what? 6.7, 6.67. Is it carbon? Is hydrogen, Is hydrogen. Is hydrogen. This is hydrogen. Okay, just a moment. It's 6.67, and then carbon is 40, and then the other one is 50. Carbon is 40, and then this is 53.77. Okay. Oh, 53 point 53 point. Am I growing up? 53.333. Yes, 53 .333. Okay, now that's the mass, the percentage mass. And then what about the molar mass? Molar mass. The molar mass of this is 12. The molar mass of this is 1. The molar mass of this is 16. Then now after that, let's divide and then find out what is it. When you divide, it's gonna be 40 divided by this, 40 divided by 12, and then 6.67 divided by 1, and then 16. No. 53 divided by 0.333 divided by 16. So here the answer you get, I don't know. You have to calculate and find out. This is 3.33, and then because this is 1, it's gonna be 6.67, so it's obvious. And then if you divide here, what are you going to get? 3.33. You see? So basically the ratio is going to be is 1 to 2 to 1. Yeah, if I divide by 3.33 divided by 3.33 divided by 3.33 divided by 3.33 33. So I'm going to get this more ratio. So now, what does it mean? It means that carbon is 1, hydrogen is 2, and oxygen is 1. So that is the empirical formula. But the molecular formula, they say that when you equate this, it's going to be 60. Therefore, I'm going to say that carbon, I'm going to put an N here, so that I know. Carbon is 12 plus hydrogen, which is 1 times 2, because there are 2, plus oxygen, which is 16. So what is the answer here? When you add all of them, you're going to get 30. 30, but 30 times n. So it's going to be 30n, which is equal to 60. So divided by 30, divided by 30. So I'm going to get n is equal to 2. So is that the answer? I doubt. Is that the answer? I doubt. So they're saying the empirical formula. We are done with that. The molecular formula, then therefore the molecular formula is going to be C. We say the C. In this case, remember I have N each here. N here, because I put it outside here. So it's going to be, C is going to be 2. Hydrogen is going to be 2 times 2 is 4. And then oxygen is going to be 2. So basically, that is the molecular formula they are looking for in that regard. Class, are we together? Let me know. Even I'm writing. I've written already, though. Haven't. Paper 2 is already. I thought everyone is done. No. Someone is saying, I thought, no, it's not done. We're going to have more classes on this physical science, because there are so many people who are basically struggling. Parktown boys, we have written already. Just I wanted to know how well I did. Oh, it means that you wrote a different paper. Yeah, because there are some schools where they write different papers. Yes, they write what? Different papers. Yes, depending on the school. But thank you very much, Butumelo. Yes, where are you from? Gauteng Metric are writing tomorrow. Yes, Butumelo. Yes, it's Gauteng. They are writing tomorrow. Tomorrow they are writing. But finals, I'll be here, guys, for you. Full swing. Make sure that you prepare questions. I'm here to help you guys. Tell your brothers and sisters, grade 11, 10. I'm also projecting there next year from 10. Yes. So, all right, let's continue, guys, to the next question. I think we are done with the first set of organic chemistry. Let's go to the next question. The next question. What is it saying? All right, guys. Ne? Yeah, guys. If you check this physical science, the problem is where the problem is coming from is that students don't give chemistry time, yet chemistry is the simplest. Don't talk about physics versus chemistry. Physics is much more harder than chemistry. Chemistry is nothing. You just don't have love for it. But since you are here, it means that you have love for it. Ne? I love you guys. Ne? Let's go to the next question. Ne? Life is good if you make it good. Yeah. If you don't like chemistry, how will chemistry like you? Obviously, if you don't like me, I'll also say I don't care, man. All right, but if you like me, I also like you too. So that's chemistry. That's what chemistry is saying. If you don't like it, definitely you will say that I don't like you too. All right, let's leave that and then we continue the next question. I'm saying that the vapor pressure. So this is another question concerning about organic chemistry. So you're done with the nomenclature. I hope you guys gonna get all the marks there. Ne? Yeah. The vapor pressure versus the temperature of the pressure graph below was obtained for four straight. This is a key point. And branched. So they are talking about it. P, Q, R, and S. From P to Q, P to S, each compound differ from the previous carbon by this. It means that it belongs to the same homologous series. That's what it means, because that's how homologous series the same homologous series, the members, that's how they keep on changing. They are being changed by just this. The vapor pressure are mentioned in millimeters of mercury. This means millimeters of mercury. 78 millimeters of mercury is equal to 1 atmosphere. Yes. Okay, they're saying the atmospheric pressure is 760 millimeters of mercury. All right, let's continue. Give the reason why alkanes are said to be saturated. Whenever I talk about saturation, it means that they have single bond between carbon atoms. Don't say that they have single bond. Where are the single bonds? They have only single bond. That word only must be put in bold, underlined, and in italics. That's the meaning of how important that only is in that definition. They only have single bond between carbon atoms. They only have single bonds between carbon atoms. Yeah. In other words, they don't have any multiple bond. Multiple starts from 3. They don't have any multiple or double bond. So because if you can say multiple, but multiple starts from 3, what about triple bond? What about a double bond? Still, it is not saturated. So it's better to say that only have single bond between carbon atoms. Anyway, let's go to the next question. Vapor pressure. What is vapor pressure? When you talk about vapor pressure, is pressure exerted by the vapor in equilibrium with its liquid. When we stop there, we're going to cross it. Don't forget that these questions are or you get it or you get nothing. Is or not you or nothing. No, it follows that. Either you get all the marks or you lose it. So now people always say that pressure exerted by the vapor in equilibrium with its liquid. The answer becomes wrong. It can only be correct if you add in a closed system. Yes. Yeah, they are saying that now. Use the information in the graph below above to answer the following questions. What is the effect of increase in temperature on vapor? Obviously, when you hit something, it boils more. The pressure increases. The vapor pressure increases. Don't forget that we say that. Look at it. When you increase the temperature, what about the vapor? At 0, the vapor was here. At 40, check, the vapors are increasing. At 80, what about the vapor? The vapor keeps on increasing. So increasing temperature increases the vapor pressure. In other words, don't say that increasing vapor increases the temperature. No, 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 no. It's not like that. The temperature does not depend on the vapor. The vapor depends on the temperature. So increasing the temperature increases the vapor pressure. If they ask you to describe something, and then if you give the reason, it means that you are giving more kinetic energy these molecules so that the bonds are breaking and then they can escape now. You understand? And then as they escape, they bound with the walls, and then the vapor increases. Anyway, one is going to ask you that. All right, let's go. They're saying that what is the effect? We are done with that. Increase, decrease. Oh, just choose. The answer is increase. Which compound has the boiling point of approximately 68? This is always. Give a reason for your answer. Okay, let me first clean up here so that we don't mess up. We don't mess up. We don't mess up. We don't mess up. All right. 68, 68, 68 temperature. What are they saying now, man? Which compound has the boiling point? Approximately 68. Ne? So you have P, Q, R, and S. So, here they are saying that boiling, so it's around here. You see, it boils here. You see, because this is the vapor, this is the atmospheric pressure, it must be equal so that something can boil. They said it here, 760 millimeters of mercury. So it means that whatever is here, it is boiling now. So now, if you look at it, here is the, if this is 60, maybe this is this, somewhere here. That's why they say approximately 68. Give a reason for answer. Yes. What are you going to say? It is the temperature where the vapor pressure of Q equals the atmospheric pressure. Yes, which is actually 760 degrees. So in other words, if you look at the graph, that's where the two intercept. This one intercepts with this. So therefore, that's the boiling point of that. So sometimes when you ask you questions, they're a bit tricky, and then you have to at least to look at what is being given so that you are able to answer those questions. All right, let's continue to the next question. Let's go to the next question. All right. They're saying that which compound has the longest chain length? Which compound has the longest chain length? If you look at the longest chain length, will mean that it has the highest boiling point. Yes. Why? Because the higher the number of carbon atoms, it means that the intermolecular forces of attraction will increase, and then the boiling point is going to increase. Actually, it's S. Why? Even you don't know what is the boiling point based on this experiment. The means that its boiling point will be there far. If we project, it will be around 100 and maybe 50, somewhere. Yeah. So they're saying that which compound has the longest chain? Explain your answer. So basically, what you can say that at a given temperature, at any given temperature, basically S has the lowest vapor pressure. If you look at it, né? It has the lowest vapor pressure. No, there is the lowest vapor pressure. Yes, because if you have check. If you check here at this temperature, at any given temperature, check. Let's consider this. Let's consider this. At this, maybe 90. The vapor pressure here is, check where it is. What about this one? What about This one, it will be very far. What about this? It will be very far. If I compare this, you see that, and then this one, it will be a little bit higher. And then this one will be higher. You see that this one has the lowest vapor pressure, meaning that the higher the vapor pressure, the lower the boiling point. And the lower the vapor pressure, the higher the boiling point. So basically, that's why we say that this one has the highest boiling point. And then it means that the intermolecular forces of attraction between they are more, or they are strong, and then it requires more heat to break this. Hence, it has a higher boiling point. Compound P has 5 carbon atoms. Let's look at compound P. 5 carbon atoms. Draw the structure formula of compound P. Write down the APAC name. Compound P has draw the structure formula. Wait, because they said something here on top, and they say that they are straight and branched chain. You see, but what do they want? They don't want compound P. They want the isomer. So what I'm going to do? 5 carbon atoms. Yes. How many isomers can it form? 5 carbon atoms. How many isomers can it form? It's 1, 2, 3, 4, 5. Okay. 5. Isn't it? So the molecule is like that. But they're saying isomer. So I can bring this here. It becomes an isomer. Or I can bring now it's gonna be 1, 2, 3, 4. And then I put another one there. So the rest are hydrogens. You see? That's the first isomer. I can still bring this here. And then it becomes 1, 2, 3. I put there and I put there. I change it into, is a primary, into a secondary, or into a tertiary. You see? I put, guys, you must always put hydrogens here. Yes. Done. So it can either be this or it can be this. Depends on what I want. Let's go to the next question. IPAC name. So you choose whatever you want. So it's gonna be 1, 2, 3, 4. So it's 4. So it's gonna be butane. But it has a side group which is methyl. 1, 2. So it's gonna be 2 methyl butane. Oh, this one is gonna be 1, 2, 3. 1, 2, 3. 1, 2, 3. So it's gonna be propane. But it has 2 side groups, which is methyl. So it's gonna be 2 methyl, 2 dimethyl propane. Simple. Let's go to the next question. This one is also about the boiling point, vapor pressure, but it requires you to explain the intermolecular forces of attraction. Yes, at least you need to explain the intermolecular forces of attraction. So what is boiling point? We have seen it, that basically vapor pressure, a boiling point. What is exactly, we say that make sure that you talk about the vapor pressure equal to atmospheric pressure, and it must be in a closed system, and this vapor must be in the dynamic equilibrium with its liquid. So basically that's how you can get the mark. Then I'm saying that curve P, that's bad manners. What is bad manners? You just got the question without reading the statement. You always get 0. Relationship between boiling point, and the number of carbon atoms of straight chain alkanes and carboxylic acid, alcohol. Oh, carboxylic acid, alcohol. Okay, sharp. They're saying that now. Graph P, write down conclusion that can be drawn from the above results. P, where is P? For graph P, write down the conclusion that can be drawn from above results. Basically, as the number of carbon atoms, let me check number of carbon atoms. As the number of carbon atom increase, the boiling point also increases. Don't say boiling point increases, leading to increase in the number of carbon. As the number of carbon, because this is independent, this is dependent. As the number of carbon atom increases, the boiling point also increases. Identify PQR that represents each of the following. Alkane. Remember that alkane has only London forces. Alcohol has London force and and hydrogen bonds. Ne? Yes. And then carboxylic acid has dipo hydrogen bonds and London forces. You understand? So it means that now it's able to have a higher boiling point. So definitely this is gonna be carboxylic acid, then this is gonna be alcohols, and then this is gonna be alkanes. Yes, because of the boiling points are low. They're saying that represent each of the following. Alkane, we have seen it. Alkane is gonna be P, and then carboxylic acid is gonna be C. Explain the answer you have mentioned above. Yes, because alkanes they only have London forces, which require less amount of heat to break the intermolecular forces of attraction. Hence, their boiling point is low. While carboxylic acid has London force, dipo force, and hydrogen bonds, which require large amount of heat to break those intermolecular forces of attraction. Hence, their boiling point is a little bit what? Is a little bit higher. Yes, I think I'm clear there. Let's go to the next question. Now we are done with the physical properties. Now this one I'm just going to do one question regarding to the reactions of this organic molecule. Then after that we can go to other questions until we reach the is there any question? Let me check and see. There is no question being asked. If there is no question, let's go to the next point. Guys, if you have a question, let me know. Ne? Mutumero, do you have any question? Mutumero, are you here? I don't know how you call it. Boy Tumelo. Okay. All right. Just a moment. Technology. All right. They're saying that the diagram below shows how alcohol, yes, P, can be used to prepare other organic compounds. A to E represents different organic molecules or reactions. X, Y, and Z are organic compounds. Okay, sharp. Let's go. Then they're saying that A, what are they saying? Okay, here you have an alcohol, which is a secondary alcohol, because the carbon atom with OH has two other alkyl groups. Okay, sharp. This one, when is alkane. What about this? When I add this is alkene. When I add the hydrogen, then definitely it's going to become alkane. And then, even the condition, you can see it. You're adding hydrogen. And then, compound X, bromine. So this is substitution because I'm adding this. Then if I'm taking it back, it's gonna be still hydration. Is still substitution. But when I go to this, then because I'm gonna remove the hydrogen, the bromide, so it's gonna be dehalogenation. So it's gonna be elimination. So okay, now let's go to the question. Is P primary, secondary, or tertiary? Is a secondary alcohol. Okay? Why? Because the carbon atom, this carbon atom with the OH group, yes, has two alkyl groups, or it has two carbon atoms attached to it. They're saying that Write down the type of elimination that takes place at A. So where is A? Is A. So from here, from here to here. So I have, so meaning that alkene, meaning that I introduce a double bond. So it means that the water is going to be removed. Therefore, it becomes dehydration. And then they're saying that, so we're done with that. Additional reaction that is represented by B, where is B? From here to this. So it means that I'm adding this alcohol. So I'm adding from double bond to an alcohol, meaning that I'm adding water there. OH. Let me just say OH. So it means that I'm hydrating. So meaning that the answer here is gonna be hydration. Then I go to elimination that is represented by D. So because this compound was, I want the compound to be like this. So only to form like this, yet it had a halogen on it, and it's one halogen. You see, it is one halogen. So I'm going to remove the hydrogen and the halogen. So it's going to be D because I'm removing. So I'm going to say D. What am I removing? I'm removing a hydrogen. So it's going to be D hydro. Yes. And I'm removing a halogen. So it's going to become D hydro halogenation. So I'm removing the hydrogen and the halogen. Hence the name dehydrohalogenation. Then we go to the next. Sodium hydroxide is used as one of the reactants. Sodium hydroxide. Yes. Okay. So sodium hydroxide is used as one of the reactants. Where? Okay. Write down. Where? Oh, here in this reaction C. Let's look at reaction C. Let's clean up this so that we see exactly what they are saying, so that we don't get confused. C. Yeah. Sodium is used as the sharp. In this case, it means that it's sodium hydroxide. Sodium hydroxide. What type of reaction that takes place there when sodium hydroxide is used? So from here to here, you understand? It's basically you are substituting a halogen with the OH, meaning that you can say it's a substitution reaction, but because we are using this, then it can also be hydrolysis, or you can say substitution. Yes. And then they are saying that write down state 2 reaction condition for this reaction. So what are you going to say in this case? This is sodium hydroxide. But how about sodium hydroxide? It can either be concentrated sodium hydroxide or dilute sodium hydroxide. Because it is hydrolysis, therefore it's going to become dilute. So the sodium must be dilute sodium hydroxide. So, or you can say dilute strong base, because sodium hydroxide is a strong base. Yes, so dilute sodium hydroxide or strong base. And then we can have, sometimes we heat or moderate temperature, mild heat, or warming up, mild heat. Yes. Or sometimes you can say addition of water. Yes. To change from a halogen into an alcohol, you require the sodium hydroxide or dilute strong base, and then mild heat, and then plus you can say just add some water there so that the reaction can take place. Then we got the next question. They're saying that write down the IPAC name of X. Where is X now? X, yeah. How do I know that X has this number of carbon atoms? It's because of the number of carbon atoms we started with. So it means that I'm gonna be able to know how many are they. It's 1, 2, 3, 4. So definitely it's gonna be replaced here with a bromine. So it's gonna be 1, 2, 3, 4. So it's gonna be butane. Ne? But it's gonna carbon atom number at 1, 2, 1, 2, 3. So it's gonna be 2 bromo, 2 bromo butane. Basically, that's what you are going to write. 2 bromo butane. Question: write down the formula of inorganic reactant needed for D. Where is D now? Where is D? It's here. From here to alkene. From haloalkane to alkene. Basically, here we add either sodium hydroxide or potassium hydroxide, so that now the sodium hydroxide can remove the bromide. Yes. So that's what you can write. That's the inorganic compound we are talking about. Use the structural formula. That's where the problem comes from when students they are asked to write the structural formula. Use the structural formula. Write down the balanced equation for E. Where is E? Yes, from this to this. Don't forget this is hydrogen. So you'll find out people adding that like that is wrong. It becomes wrong. Let's look at it. What you are supposed to write. So basically it's gonna be, remember all of them are going to be 4 carbon atoms. So it's gonna be 1, 2, 3, 4. Even the one which I'm gonna form is gonna be 4, isn't it? Yes, I'm going to add the hydrogen plus hydrogen. Remember, even hydrogen must be in that formula. You see? Yeah. So basically, what am I going to add? It had a double bond. Let me check and see. Yeah, it will use mechanical fluid and then sharp. So it's going to have a double bond. So the double bond is going to be there. The rest are hydrogens. You put them hydrogen. You put hydrogens the way they are supposed to be. Because I'm adding hydrogen, so it's a simple thing. Yes. This one must also be like this. So you put hydrogens throughout, so that you get a mark there, and you also get a mark there. I think it's 3 marks, ne? Let me check. Yeah, it's 3 marks. So basically, that's how you can get those 3 marks. Then we go to the next question. Write down the APAC name of Z. So Z, where is Z now? Oh, the product. So what are you going to write here? The product here is simple. 1, 2, 3, 4. So it becomes butane. Simple. Butane. Let's go to the next question, which is now more calculations. So now section A, or the organic questions related to organic, they are done. It means that you are able to answer all those questions concerning about that. You understand? Question A is what is done. So let's continue to the next question. Tomorrow is saying, yeah, I'm here. All right. You know, but tomorrow you are my daughter, ne? So when you are not here, yeah. When I say you are my daughter, and Elana from Parktown says they didn't write the same paper. They didn't write the same paper. There are some schools which write separate papers. They write separate papers. Yeah, they are given. Different schools can write different paper depending on how do they perform. Yes, only finals is the same. Yeah, only finals. Yeah, that one there is no doubt. There is no debate about it. Ne? Yeah, there is no debate about it. Yeah, tomorrow. I think I'm clear there. All right, let's go to the next question, guys. If you have any question, let me know. If you don't have a question, let's go to the next question so that we smash it, so that we go to the chemical equilibrium, acids and bases, and then we finalize with the electrochemical cells and electrolytic cells. All right. It's saying that the reaction of zinc and the excess hydrochloric acid is used to investigate the factors that affect the reaction rate. Guys, this word excess is very, very important in this question. Very important. Why? Because this cannot be a limiting factor. Whenever you say excess, it means that it cannot be a limiting factor. So you have to put focus on it. There is a question which is going to be related to it. Yes. So guys, make sure that at least your focus and then look at why did they say that excess. They're saying that balance equation is there. Zinc plus hydrochloric acid give you zinc chloride plus hydrogen. The reaction condition used and the results obtained for the for each experiment are summarized in the table below. And then there's same mass. This word same mass of zinc is used in all experiments. The zinc is completely converted in all reactions. Then the reaction time is the time taken. They're saying reaction time. They're not saying the rate. Time taken for the reaction to be complete or completed. All right. And then they're saying that experiment number 1. Yes. Experiment number 1 and experiment 5 are compared. 1 and the 5 and the 5. So they compare. So they selected those two. Okay. Let's see what they're saying so that we can know what they're saying. Write down the independent variable. Write down the independent variable for experiment 1. For experiment 1 and the 5. Because they're saying experiment 1 and 5. Guys, let me say this clearly to everyone. Whether you are here or you watch this later. Question concerning about rates of reaction are one of the simplest questions to answer. But they are one of the most difficult questions students have failed because it is an application question. So please take note whenever you are answering these rates of reaction questions, please don't rush. Sometimes we hide something and tends the learner to. There is a simple research I did. It was from 2008 until it was 2018, yes. The most failed question was that. Yes. So under my research, I found out that. So I need to now to check and see what is happening in these years where I didn't do the research. So please don't be a victim for this. Yes, let's continue and then so that at least we answer those questions. So they're saying that question 1, okay, this and this is the same, this and this is the same, you see. So they cannot affect, it's powder. So what is affecting? Is temperature. Let me see the temperature. Yes, the temperature is affecting. So what is independent there is the temperature in this regard. What? No, this question this is not supposed to be zinc. It's not supposed to be hydrochloric. State of division for hydrochloric powder. There is no hydrochloric acid is a powder. It's supposed to be zinc chloride. I think the people. Where am I putting that to? Yeah, it's supposed to be zinc chloride. Yes. So that's the answer. The answer is 10 in that regard. Yes. The answer is what? Is 10. Do I say 10? The answer is not 10. The answer is temperature. They're saying define the rate of reaction. Change in the concentration of reactant or product per unit time. When you say is the rate of change in the concentration of product or reactant per unit time, the answer is wrong. Can I repeat? When you say is the rate of change in the concentration of product and reactants per unit time, the answer is wrong. Because you are saying rate, which means time. So you are repeating the same question. So when you use rate, you don't use per unit time. You understand? But why do you use rate when they ask you to say rate? What is rate of reaction? Why are you using the same word they have asked you to define? So it's better to say that it's the change in the concentration of product per unit time, or is a change in the concentration of reactant per unit time, or is a change in the concentration of product or reactant per unit time. Yes, so I think I'm clear there. Please don't be a victim for that. We go to the next question. They're saying that write down the value of x. Where is x now, man? X is here. Oh, is there any other? How am I going to get this? Okay, let's compare this and this. They are the same, no? And this. Okay, let me underline it. This and this is the same. This and this. Don't forget the temperatures. This is hydrochloric acid, but they said it here. They said it that hydrochloric acid is already in excess, meaning that increasing this volume, it will not do any change. So definitely this is 14. You see, it's an application question. You have to, see how you manipulate that question. Yes, because you see how excess is used now. They are saying excess. They said excess. So increasing any volume of that doesn't change anything because they didn't say they have increased the concentration. Yes, the concentration is the same. So increase in the doesn't change anything. Yes, yes. Then we go to the next question, which is Maxwell distribution curve. Yes, for particles. Experiment 1, 3, and 5 are shown. Okay, A, B, and C that represents experiment. So they want you to identify A, B, or C that represents experiment 3. So how are you going to identify this? Okay, let's come back here. They said experiment 1, experiment 3, and experiment 5. So they're saying that which one? Let me see this. What time is 25? Experiment 3. No, time is 7, time is 5, and time is 4. Okay, now they're saying that experiment, give the reason. Which one is experiment 3? Which one is experiment 3? So if the question comes like that, let's look at the temperature. Which one is experiment 3? Look at the temperature. Temperature, no. I don't think so. Let's look at one, the volume of the concentration of this. Yeah, this one has a higher concentration. And this one has a higher temperature. But temperature, okay, if I say temperature, you see that is gonna fall more on this side. So definitely C is gonna be for temperature, which has the highest temperature. And then the one which is on more particles, so it's gonna be the one which has the highest concentration. So basically 3 is gonna be B, because it has the highest concentration. More particles are trying to what? To react. Has the highest number of moles. In other words, you see that its moles are a lot. And then 5 is for the temperature, so it's gonna be C. Why are you saying that? Because it has the highest temperature. More particles will have more sufficient energy. It will have more sufficient energy. You understand? Yes. So that now the reaction can what? More will form products. Why? Because the energy those particles they're having, they are more than activation energy. So more particles will become products. So that's why you see that here. Do you see how these questions are a little bit tricky? And because they're not straight out, so people, they tend to lose it. Experiment 6 is now conducted using a catalyst. Experiment 6 is now conducted using a what? A catalyst. So what happens about the catalyst when it's applied? The rate of reaction is going to increase. So the same reaction condition as experiment 1, meaning that same reaction condition. So they're asking you, how will heat, what is the function of the catalyst in this experiment? To speed up the rate of chemical reaction. That's it. To increase the rate of chemical reaction. That's it. How will the heat of reaction in experiment 6 compared to experiment 1? How will the heat of reaction? They said same conditions. You understand? Same condition. You have not changed any condition. You just increase the speed at which you are moving. You're supposed to reach there after 2 hours. You just reach there after 4 hours. The destination is the same. So it's going to be the same because the catalyst does not change anything. It only alters the speed at which the reaction is taking place. Therefore, the answer is going to be equal to, yes. Calculate the average reaction with respect to zinc in experiment number 2. So what are you going to say here? The average reaction. So now you have to know, because zinc, you find the number of moles, yes, of which is mass over molar mass. I have the mass. Therefore, number of moles is going to be equal to 1.5 divided by zinc. Zinc is 65 from the periodic table. Okay? So the number of moles is going to be equal to, you find is maybe 0.023. Use your calculators, then this is moles. Did they say the number of moles? No, they are looking for the speed at which it is taking place. So this experiment is that experiment number 2. So experiment number 2, the final time is 14. So meaning that is going to be change. So it's going to be change rate, don't forget, is equal to change in the product or reactant concentration over change in time. Over change in what? In time. So it's going to be 0.023 minus 0. Yes. Final minus initial. Then divided by 14. That's the final. 14 minutes minus 0. So after that, you divide this by this. So the answer you get is around 1.65 times 10 power negative 3. But now these are moles per minute, because this is measured in minutes. Unless you had converted it into seconds, measured in the minutes. Unless you converted it into seconds, then that's when you can talk about that. Okay. Is there any question you would like to ask or to know about before I go to the next question? So that's rates of reaction. Sometimes we ask you a question concerning about rates of reaction, and we ask you that what are some of the factors which affect the rate of reaction? So you have to know how to deal with that. You know? The factors which affect the rate of reaction, you have to know all of them, and which one affects the gases only is pressure. Pressure occurs in what? In gases. So please make sure that you know at least that. When you go to the next question, yeah, it's about still the Maxwell distribution curve. This one, the reason why I like it is because whenever they bring it, students tend to fail. They tend to fail. Let's go to the next. Study the Maxwell distribution curve for this reaction. You have PQR, all right. The shaded area, those are the particles which have sufficient energy to form products. And then the unshaded area, those are the particles which don't have sufficient energy. Their energy is not equal or more than activation energy. You understand? Yes. So when you do the temperature, you will see that most of them, they will go, more will be there. And then when you do the concentration, it will increase a little bit up because you have increased the number of what? The number of particles. Yes. So you need to know when the temperature is applied, when the concentration is applied. You need to know how to redraw that graph. So P and Q are labels for axis. Okay. What quantity is represented by Q? By P. So you have said it. P is the kinetic energy. It shows the kinetic KE, kinetic energy. And then Q shows the number of particles or number of molecules. We don't know whether they have sufficient energy or we are just talking about the number of molecules as we go up, the number of molecules in this reaction. You understand? Yes. R represents the minimum energy required for the reaction to take place. Write down the term under this. We call it, how do you call that energy? The energy is called the activation energy. You understand? Then they're saying that write down the term. Okay, we are done with that. How will the shaded area of the graph be affected when the catalyst is added? Choose, increase, decrease, or remain the same. How is this shaded area? When you apply a catalyst, you are lowering the minimum energy required for the reaction. You are giving it an alternative pathway, which is a bit quicker. Yes? Yeah. So it's like they ask you, you are going to, for example, to Europe. You can use a plane or you can use a boat and then use the ocean, sea. So, but sea is going to take you longer and energy. So when I bring you a ticket for the plane, is an alternative way to reach there. Simple and easy. So when you apply the catalyst, you are making an alternative way how you can reach there. And many are going to do that. Check when you're using Istimera, the train. The train. You're using the train to go wherever you want to go, or you are using the taxi to go wherever you want to go. How many people in the train? And how many people are in the taxi? You see that people in the train, there will be a lot going because it's a little bit cheaper. So that's what catalysts do. They give alternative. Therefore, you will see that more individuals here, they will be having a lot. You will be having a lot of them. Yes. When the catalyst is what? Is applied. So basically here is going to be increased. Why? What I can say? Catalysts provide alternative pathway or lowers the activation energy. You understand? More particles will have sufficient energy, and then you're going to have more effective collision per unit time. That's what the per unit time. Don't write it, you lose it. More effective collision per unit time. You understand? And then this increases the collision. Then this increases the rate of what? Reaction. So basically, that's how you can explain using the collision theory. Yes. Before I go to chemical equilibrium, let me check. Yeah, I still have a bit of power. Electricity went a long time. I hope it will make me survive. So before I go to chemical equilibrium, because now you are going to chemical equilibrium, so that we can also tackle it. We can also tackle it, and then we see what we can do. They're saying that I'm from District 11, Gauteng. I'm asking because I see some from Gauteng school saying they. Guys, stop that habit of some. Anyway, they wrote you have not. Let's focus, guys. Let's focus. Everyone has a destiny. So our destiny is tomorrow, and we have to crush it. Ne? We have to crush it. We have to crush it. Yeah. All right. Don't stress about those people who have written of which you will never write the same paper. Ne? Yes. Uh-oh. Yeah. You will never write the what? The same paper. Okay, guys. Oh, I was saying that before I go to chemical equilibrium, let me just talk about this simple graph. I think you know it. You know it very well. When I have a graph like that, what does it mean? It means that this is it. You start from a low energy to a high energy. Therefore, it is an endothermic reaction. When I have this graph, uh, you start from a high energy to a low energy. Therefore, that's exothermic. You have released energy to the surrounding. How do we call this A and B? These are products, these are reactants. C plus D, these are products. But this is for reverse reaction. This is what? Reactant, this is product. How do you call this energy? This is the activation energy. This is the activation energy for the forward reaction. But from here to here is activation energy for the reverse reaction. So you have to know all this. Yes. And then change here. It's basically the enthalpy change. Did I say yes? No. The energy products have, and then here the energy reactants have, and then when I have this difference is the enthalpy change. So you guys, and then you have yes the top here, the species which are always here, we call them activation. Activated complex is a complex which is in the transition. It's not a reactant and it's not a product, but it's in the transition to form products. So when they ask you what's the activated complex is a species which is in the transition of forming products from the reactants, meaning that they are not yet products and they are not yet what? They are not reactants. So guys, let's continue to the next question and then we see what we can do to, yes, chemical equilibrium. Yeah, chemical equilibrium. Guys, any question? No question. All right, let's go to chemical equilibrium. You're saying carbon dioxide reacts with the carbon to in a closed system. Carbon dioxide reacts with the carbon in a closed system to produce carbon monoxide, according to the following balanced equation. So this is what you have. What does the double arrow indicate in this above equation? What does this double arrow indicate? The double arrow indicates it indicates that the reaction is reversible. It's a reversible reaction. You understand? Yes. Is the reaction an exothermic or endothermic reaction? Basically, this reaction is an endothermic reaction. Why? Because the enthalpy change is greater than 0. It's an endothermic reaction. It takes in heat. This is what I said here, that if the enthalpy change, you start from here and then it end up, it is endothermic reaction. Start up and down, it is exothermic reaction because it releases heat. Guys, when you take a deep breath, how do you feel? You feel good, man. You feel relieved. You know how you are relieved? You took energy out. Even you feel that you are releasing the energy, exothermic. You were hyper, now you go down. You feel cool. That is how exothermic reactions are. They start from up, they go to the low. But if someone makes you angry, what happens? You feel it. You feel the heat inside you. Yes? Why? You are collecting the heat. You are absorbing. You feel like yes, that's the meaning. That's when you're going to fight. That reaction is called endothermic reaction. You are taking in heat, and that reaction, when you are cooling down, then is an exothermic reaction. Yes. Anyway, and then when someone comes, okay, let me read it. Let's go to the question. Yeah, so it is an endothermic reaction Reason why? Because the enthalpy change is greater than 0 or the enthalpy change is positive. What does double R? Okay, we done that. Initially, a known amount of carbon dioxide is exposed to hot carbon. Okay, initially, this is very important. Container at equilibrium, and then the reaction at this is this. Okay, the Kc is 14, and then they're saying that equilibrium found that this is the number of. So you see what I'm highlighting. This is what is given. You need to know that before you go for any calculation. So they're saying that how will the equilibrium concentration of the product compare to that of reactant? Choose from equilibrium concentration of product compared to that of the reactant. Definitely, because the Kc is greater than 1. Yes, therefore the product is going to be more. Look, if I have Kc and then I have product is 2 and then the reactant is 1, what is the Kc I'm gonna get? I'm gonna get 2. What about if I have the Kc, the product is 1 and then the reactant is 2? I'm gonna have 0.5. So if the products are more than the reactant, the Kc is gonna be above 1. And if the products are less than the reactant, the Kc is gonna be less than 1. So in this case, the Kc is 14. Therefore, I'm going to say that the products are more than the reactant. I think I'm clear there. Then I got to the next question, which is calculate the initial mole of this. So how am I going to calculate the initial mole? All right, this is what you're going to do. Let's use our rice method. It depends on what you have been using. Let me draw it here so that you see exactly as I'm calculating, you see exactly what you are supposed to use. So if I say I'm going to use my rice method, rice, I like to add another E at the end so that I know the concentration. Rice, so in this case, they say that what is the reaction? They're saying that carbon dioxide reacts with the carbon, giving me this, but this is a solid, so I scoop it out. Therefore, it's gonna be carbon dioxide. It's gonna be carbon dioxide. It's gonna give me carbon monoxide. You understand? So carbon dioxide is reactant and carbon monoxide is the product. Mole ratio it's 1, and then here it is what is 2. What is the initial mass? What is the initial? We don't know. Let me call it initial. This means ratio. This means what you started with, the initial. So in this case, we don't know because that's what they are asking us to calculate. They say that calculate the initial amount of moles of carbon dioxide. So let me call it X, or I can call it Y or Z, whatever. Yes. And then here, products, they always start with a 0 unless they say it that maybe they added at this, you understand? So what is at equilibrium? At equilibrium, we don't know. And then here, so what is used, we don't know. C means what concentration and what is being used. And then what is at equilibrium. You understand? So how am I going to get this? I don't have anything here. But they gave us here a clue here that they say that 16 grams, 168 grams of carbon monoxide is present when at equilibrium. So these moles are present here. But these are grams, so I have to convert it into moles. So I'm going to say that number of moles is equal to mass over molar mass, of which mass here is 168 divided by the molar mass of carbon monoxide. Carbon monoxide is 12 plus 16. 12 plus 6 is 8, is 28. Yeah. It gives me 28. Yeah. 28. So when I find the number of moles here, the number of moles is going to be 6 moles. You see? So it means that what I produced is 6 moles. What was at equilibrium is 6 moles because these are product. But now, since this is what is there, so I need to know how much is there because this is what is used. So it means if I have 6 is 2, 1 is going to be what? Is going to be 3. So now it means that I can find what remained at equilibrium. Therefore, I'm going to say x, this minus this, I get this, x minus 3, so that I get what is remaining here. So at equilibrium, the concentration at equilibrium is going to be 6 divided by the volume. The volume was given here is 2 divided by 2, so it gives me 3. And then here is going to be x minus 3 divided by 2. You see? That's how you keep on calculating. You make it a table, eh? Yes. So now it means that the Kc, which is equal to 14, they said it here, it's 14 is here, is equal to the concentration of carbon monoxide, but the concentration of carbon monoxide is 2 is 2, so exponential 2, and then carbon dioxide is 1. So of which this one is gonna be 3 squared divided by x minus 3 divided by 2. You understand? After that, now you guys are mathematicians, you can calculate it. Ne? Okay, 14 is equal to, I reciprocate this. Ne? I reciprocate it, and then it becomes 3 squared is 9. Ne? 9 times 2, I bring this one up, divided by x minus 3. You can use any method, yes, of which this is 9. Eh? This is 9. So which is going to be, I bring this one this side, so it's going to be 14x, then 3 times 14, 3 times 14 minus 14 times 3 gives me 9 times 2, which is 18. You see? So you calculate and find out what is it. So this I bring it this side. You see? I bring this side, and then I get what is x. The x I get is actually what is here. So it's approximately 2. Is it 2? No, it's approximately 4.28. 4.28. 4.28. So that is the number of moles. Yes, what is here. So that's how you guys are supposed to keep on calculating. We bring these questions in 3 phases. We can bring this question when we have hidden the concentration. The problem is here. We have hidden the concentration of the reactant, or we have hidden the concentration. We don't know the Kc, or always the problem is here. So what you need to do is initial minus what is remaining. In most cases, you get it from this side. You get what is remaining at equilibrium. So you divide. Then after that, you can replace it in the, or you can substitute it in the what? In the expression, so that you get the actual answer. It's saying 3 not x. Sir, where does x come from? Okay, Rumelo is asking me, where does x come from? Okay, let me show you. I said x here. Yes, I said x here because they say that we don't know the initial amount. Check, they're saying calculate the initial amount of carbon dioxide. Carbon dioxide is here. It can't be 3. If it was 3, then it would have been, you see. So I said x. I just gave it unknown. It can be x, it can be p, it can be z, it can be o, it can be n. I just used x so that I can introduce this x, the initial, and then the 3, because I started with the, I produced the 6 carbon monoxide. The mole ratio is 2 to 1. Therefore, if 6 is 2, and then 1 is going to be 3. You understand? So that now when I subtract this 3 from this, I remain with what I remain with at equilibrium. That's why I said x minus 3, which is used. I will know now, once I get this, I will know what remained at equilibrium. You understand? I hope, Boitmelo, you understand where I got the x from. Sir, do you mind to do more Kc questions? Mm. Amber, Amber, I don't mind any. I'm not minding anything here, as long as it is helping you guys to let's do more questions about Casey. Yeah, because I know that Casey really it becomes a problem to my students and other people's students. But the moment you are here, you become my student. So I'll do more questions now. Let me go to the next question. But I just pray that 37%. The system is having 37%. I hope by that time electricity will be back. But let me do another question about Casey so that at least you don't lose it. If it helps me to go for more questions, well and good. If you see me going offline, yeah, okay. Here is another question for Casey. I put more than enough for Casey because I know that Casey, all the versions they might bring. Yes. Question below represents the hypothetical reaction that reaches equilibrium in a closed system or container. After 2 minutes, this is the question. This is the key point. At room temperature, X, Y, and Z represent the number of moles. X, Y, and Z represent the number of moles. Yes, X, Y, and Z. They don't represent the concentration, they represent the number of moles. The graph below shows the number of moles of reactant and the product versus the duration. So define the dynamic equilibrium. When you talk about dynamic equilibrium, we're talking about the stage in a chemical reaction whereby the rate of forward reaction and the reverse reaction are equal. You understand? The reverse reaction and the forward reaction is the stage. It's a stage where in a chemical reaction whereby the reverse reaction and the forward reaction are equal. So I think I'm done with the dynamic equilibrium. Use the information on the graph, write down the value of X, Y, and Z. So if you look at this value of X, where is X? Oh, X is A. Oh, A, and then Y is B, and then Z is Z, Z is C. Okay, X. Mm, okay, so here this one is 4. So B is equal to 4 at equilibrium, né? And then A A A is 8, isn't it? Yeah. And then C is 12. C is equal to 12. So if I divide by 4 here, by 4, by 4, I'm going to get 1, I'm going to get 2, I'm going to get 3. So it means that A is X. A is X. Let me rub off here. A is X, né? So X is going to be, A is X, is going to be 2. Y is B. Yes, so B here shows it's 1. And Z is C, which is 3. I think I'm clear there. So just a small interpretation which is needed there. Calculate the Kc value for the hypothetical reaction at room temperature if the volume of the closed system is. So we have the closed system. You understand? So it means that we're going to use the same method of, let me now write here so that you see it clearly. Né? Yeah. So Rice method. I wrote the other side last time because just to show you how it works, but now let me use this. Rice. I say that the last E is just for concentration. So what do I have? I have A, B, and C. All of them are aqueous, so it means that they're going to apply. I have A, B, C. But what is the product? A and B are reactants, so meaning that these are reactants, definitely. So number of moles, A, we say that A is 2, B is 1. A is 2. Sorry. A is 2, B is 1, C is 3. So I know now the mole ratio now. You understand? What did I start with? I need to know what I started with. I started with what here? What did I start with? I started with 0. Obviously, it's the product. Yes, I started with 0. Check here. You see it? And then B, I started with 8. And then this one, I started with 16. Is it? Mm. I started with 16. Yes, I started with 16 here, which is A, and the B, I started with 8. You see? Let me just show you properly. You see? Yeah. So it's simple there. So it means that, oh, I'm forgetting now. B is 8, A is 16. B is, I started with 8, and then here I started with 16. Ne? Yes. Okay, now I know that now. It's simple. Now, what is the balance? Go to the question. At equilibrium, A is 8, B is 4, C is 12. A is 8, B is what? B is 4, and then C is 12. You see, it's just flowing. They can give you a question like this, simple like that, and then, but this one just to interpret the graph. And then now, what is remaining at equilibrium? Definitely this is the product, so it's going to be the same. Here I'm going to subtract 8 minus 4, which gives me 4, and then here I'm going to say 16 minus 8, which gives me uh, 8. So it's the same thing here. It's the same thing here. You see, it's the same thing here. X3. Then you see, then you subtract this from this. You see, that's the meaning. You see, Butumero. You see what I was meaning here is the same thing. But this question is just open. It's an open question whereby it's easy to get the values. So now I go to find out the concentration at equilibrium. Concentration, I have to divide by the volume, of which the volume, they say that the volume is 2. Ne? The volume is 2. Where is the volume? The volume. Oh, is the volume 2? Where's container? Yes. Yes, I'm looking for the volume now. They say volume is 2. They say that, yeah, volume is here. It's 3. It's not 2. So meaning that 12 divided by 3. So I get 4 there. And then here, 4, yes, divided by 3. So I get the answer there. You get the answer there. And then 8 divided by 3. So you get the answer there. I don't have a calculator to do that. You can calculate out. Let me check and see. So whatever you get here, now you put it in the KC value, KC expression, whereby in this case it's gonna be C is the product, né? And it has 3. Concentration of C, which is 3, over concentration of A, and over concentration of B. But A is 2. So it means that I have to square A. So now you substitute what you got here in this, and then you find the KC value. I think I'm clear there. That question is also cool, né? Then Amber, I think I'm clear there. Should I give you more question? All right. Should I give you more question on the? Okay, let's do the last question on chemical equilibrium, so that at least, guys, your happiness is my happiness. When I see you passing, it's my happiness, né? Yeah, because I will know that at least I've changed someone's marks. Maybe by 1, even if it's 1, it's fine. It's fine. The day you get 79.3, 0.4, whereby you are not only 1 mark, just 0.01. You know that for a distinction 0.01, and we can't give you that 0.01. Sorry, the system can't. Let's go to the next question, which is 18. Question 18. saying that 3 grams, guys, whenever they give you the mass, such mass, before you do anything, convert it into number of moles. You converting it is a mark because you're going to use it. So you just come here and say number of moles is equal to mass over molar mass. I don't even know what is there down. So what I need is, so number of moles is 36 divided by of steam. Steam is H2O. You understand? So H2O is 1 times 2, then plus oxygen, which is 18. Oxygen is 16, making it 18 divided by 18. So I get the answer here. At least I know the number of moles in there. You see? So you get it even before you do what? Yes, before you do any calculation. You understand? Yes. So when you divide there, maybe it's going to be around 2 moles. Yes, at least you'll get a mark there. Anyway, let's continue. Certain amount of carbon were placed in a 2 decimeter. This is important. Sealed container allowed to react. At equilibrium, it was found out that the amount of carbon changed to this. The amount of carbon, yes, changed to 2.225. You understand? Yes. So carbon and this, remember we're not going to use carbon, but they have the same mole ratio with the carbon dioxide. Therefore, I can use that as a starting point for me to calculate. You understand? So I'm gonna come here and I say, that carbon. Let me use my rice method. Yeah. I hope you will get it. RICE, whereby I have the elements here, whereby they say that, what did they say? Is the steam, hydrogen, and carbon dioxide. Because this is a gas, I don't take this because it's a solid. Please don't include the solids there. Okay? So I'm going to have steam, water, plus hydrogen. Yes. So it's going to give me carbon dioxide. Is it hydrogen is going to, no, man. Hydrogen is also a product, ne? Yes. So it means that, what am I going to do here? I'm going to say, this is carbon dioxide. So carbon dioxide starts with the 0, is a product. I'm wrong. Sorry, ne? This is mole ratio. Let's look at the mole ratio. The mole ratio here is 1, 2, 2. So it's 1, 2, even this one is 2. So what I started with the product 0, 0. I started with the product 0, 0. But I calculated the number of moles of this because they say that an amount of carbon is placed in this container. It means that this is the initial. Well, the initial mole is 2. So we get a mark for that. So I put a 2 there. Is it clear? But they say that at equilibrium, what happened? They found out this. Meaning that this is the amount of I'm going to find for carbon dioxide because it is 1, 1. The mole ratio is 1, 1. So I'm going to say 0.225. That is what is being used. And at equilibrium, I'm going to find the same thing, 0.225, because it's a product. Ne? What you find at equilibrium is what is produced for the case of product. You understand? But now, this one is 1 mole. What about this? It's going to be 2 moles. You understand? It's going to be what? 2 moles. So what I used here is going to be, by the way, even this is a product. So it's going to be the same thing. Yes, it's going to be the same thing. Because this and this are products, except this one, this side is the reactant. Now, since I know that, then I'm going to find the mole ratio here is 2. If this is 2, no, man, sorry, guys. Just a simple thing here. Yeah, I'm a human. Yeah, because this is 1, yes, 1 more, then this one is going to be 2. So it means that you have to multiply. So when you multiply by 2 here, it's going to be 0.45. And then even because it's 2 moles, here is 1 mole. So I'm using this. So 25, yes. Now, if this is 0.25, 0.45, why are 0.45 here and here? Because these are products. So what is produced is what is equilibrium. But this is a reactant. What is used minus what you started from, you get what is remaining. So in this case, since the mole ratio is the same, so it's going to be the same figure, 4, 5. But now what is remaining is going to be this one minus 2. So 2 minus 0.45. You understand? So it gives me what's the answer here is going to be 0.775. So this is the figure we are looking at. So now after that you find the concentration at equilibrium, 0.775 divided by 2, because the volume, they say that the volume is what? The volume is 2. So divided by 2. So I go to this 0.45 divided by 2, 0.225 divided by 2. So the answer I get, I put it in the expression for Kc. Kc is equal to carbon dioxide. Is it carbon dioxide? Is it carbon dioxide? Yes, carbon dioxide. And then hydrogen, but hydrogen is squared because it's 2, divided by H2O in aqueous, in gaseous form, which is 2 there. So now you substitute this, and then you find the Kc value. And the Kc value, you'll find it's there, indicated there on the paper, that I put it there so that you know. So when you calculate, you must get that actual answer. So yeah, that is the answer you're supposed to get. Yeah, I think question concerning about chemical equilibrium, we have tried to exhaust them. Okay. He's saying that, but sir, we have 2 reactants and 2 products. Yes, Butumero, we have 2 reactants and 2 products. But the reason why I'm saying 1 reactant is because carbon is in a what? In a solid state. When we are in a chemical equilibrium, we don't talk about liquids and solids. So this one, check this state, it's a solid. So we remove it out. So we don't consider carbon. If it was in a liquid, if you see the reason why they put this one into a gaseous form is because they wanted to use it in the equilibrium. If it was in a liquid state, we would have scooped it out also. Then it means that we would have used hydrogen and carbon only. You understand? Yes. So in this case, it's like that because we wanted to remove carbon, because carbon is in a solid state. That's why I have 2 products there. Okay, thank you, since you have seen it. All right, let's go to the next question, and then maybe we can see, because I see the battery is killing me here, and I still have I think 16 minutes. I hope in those 60 minutes, actually we'll be back, and then we can talk about it. Okay. They are saying that in this question, they are saying that give reason why the rate of forward reaction, the graph below shows the forward reaction and reverse reaction with the time. Give a reason why the rate of forward reaction decrease between 0 and 1, T1. Why is it decreasing? Because you are using up the reactant. Yeah. I usually give such examples. For example, let me say, because let me see, people have commented. Yes, Amber, for example, for Butumero, for example, if you have 1 million rand, and then that 1 million rand, you use it, and then you remain with the 10,000. Do you think that you're going to spend the same way you are using it, you are spending when you are still having 1 million rand? No, because you have used it is now decreasing. The speed at which this money is moving out of your account is going to be low. It's the same thing here. Yes. So it's like that because why? It's because there is a decreased um, concentration of the reactants. You understand? Yes. Then you're saying that temperature T2, what change made at equilibrium at temperature T3 here? Both changed at the same pace. So it means that there was an application of a catalyst. You understand? Yes. Is the forward reaction exothermic or endothermic? Is the forward reaction exothermic or endothermic? So what are you going to say here? Is it exothermic or it is endothermic? Don't forget it was steam. If it is steam, it requires heat. So definitely it is endothermic. When you added it, you increase the temperature. Check. If you increase the temperature here, what is happening? The temperature made it to become, the temperature will favor the forward reaction. That's why you see that the product became more product and then the reactants started to decrease. So you see that the forward reaction was endothermic. Why? Because increasing the temperature will favor the endothermic reaction. You understand? Increase in the temperature will favor the endothermic reaction. So let's go to the next question. Oh, the next question is about acids and bases. Yeah, the next question is going to acids and bases. So guys, before I continue, yes, I'm going to give you a short break. But in this short break, I'm just going to, because now I see that the battery is dying. I'm gonna come back at 6, 6 o'clock. I'm gonna come back. Why? Because of the electricity issue. But let me just give you a little bit of what? Of electrolytic cells. Yes, electrolytic what? Electrolytic cells.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel. Volatile cells. Last time we talked about electrolytic cells. We say that electrolytic cells, for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it, it is reduced. So it means that it's less reactive. It can accept the electrons. Yes, it can accept the electrons. If you are broke, it means that you can accept everything. Yes, so you oxidize others. You make others to be broke. All right. So we are saying strong oxidizing agent, it means that they can accept the what? The electrons. For them, they are reduced. So they are you put them on the cathode, the positive. Because cathode is positive, so they are able to receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of volatile cells. So I will say that this is a red cat. This is a red cat. This is a red cat. So don't forget that. I'll tell you what it means. All right. So we are saying red cat. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc, so there is a reaction which takes place here, and there is a reaction which takes place here. Yes, we say that zinc is more reactive. It is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity series. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc. Therefore, it's going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two beakers are connected by a salt bridge. Salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that they have a reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes, so it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes, you see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes, so your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes? And then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, if it forms a solid, then the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid, yes, it means that now the solution will start to fade out. Yes, to be fading. Why? Because the copper ions which make the solution to be blue, they are being used up. Therefore, now the solution becomes pale. It fades until it becomes clear. Once it becomes clear, then it means all the copper ions have been used. So you need to know those small concepts so that when they bring the question, you are able to answer them nicely and clearly. So, all right, let's compare. Let's compare the two half cells. Yes. Number 1, zinc half cell. Then copper half cell. The one we have talked about, oxidation reaction at the anode, which is always negative electrode. We know that anode is always a negative electrode. Yes. So oxidation occurs there. It means that zinc will ionize. Yes. When it ionizes, then it increases in the charge. Then obviously reduction will occur at the cathode, and it's always a positive electrode. This one is supposed to be a reducing agent because it causes this copper to be reduced. Yes? And then itself, it is oxidized. When it releases electrons, you see, it releases electrons, comes from 0 to 2. So it has been oxidized, increase in the state. While this one, it has accepted. Therefore, it's a strong oxidizing agent. It has caused this one to be oxidized. And for it, it is reduced from positive 2 to 0. You see, it has been reduced. And it has caused this one to be oxidized. It is a strong oxidizing agent because it has caused this one to be oxidized, and itself it is reduced from 2 to 0. That's the meaning. Then when you go to zinc, okay, the equation, this is the equation, what is happening, we saw it nicely, and also this is what is happening, we saw it nicely. Yes. So you read from right to left. We're going to look at it when we go to the reactivity theory. And then here, read from left to right. You're going to look at it when you go to the reactivity theory. All right. So when you're writing the cell notations, we're going to look at it and then you're going to get it better. All right. We are saying that zinc is a strong, zinc is the stronger reducing agent, while copper 2 is a stronger oxidizing agent. I've explained this. How is this is a strong strong oxidizing agent? Because it causes zinc to be what? To be oxidized. Then it becomes an agent for oxidizing. But itself is what? Is reduced. And then zinc is a strong reducing agent. Yeah, it is an agent for reducing. So it causes copper to be reduced. But itself is done what? Is oxidized. Then we are saying that the anode always decreases in mass if the reducing agent is solid. I've tried to explain it that if you look at zinc, because zinc is dissolving into the solution, then the mass must be reducing as long as it is this electrode is a solid. So it means that it keeps on reducing in size. It is corroded. Yeah, it starts to disappear. All right, and then they're saying the cathode always increase as long as it is a solid, always increase in mass if the reduced product is a solid. Yes, so we saw that since copper is a solid, if you look at it here in the equation, copper is a solid. Even you can look at it here. Yes, is a solid. Then it means that the terminal must be increasing in size always as long as it is a solid. Since now you know the concept, now it means that we can apply these concepts in different versions. All right, net cell reaction. It means that we're going to combine the half equations and then we see what we're going to form. Make sure the half equations balanced. Balance them, including the electrons. I tried to show you on the equation that the electron must be balanced. Add the two half reaction together, eliminating the electrons from both sides. So that now when you add them, then you eliminate the electrons and then it cancels out, then you form a full equation. Let's look at it. Here is oxidation, which is taking place on this side. Yes, on this side of the half cell. Zinc metal, yes, or solid, dissolves to give zinc ion plus 2 electrons. The 2 electrons, they start to move. These electrons, they will come to this side. So what happens? This one will receive. We'll receive these ones here. When they come here, and then they combine with this copper. So copper 2 ions plus 2 electrons, which came from zinc, and then you form copper solid. So this one forms a solid. It is deposited here. While this one starts to dissolve, which is this, dissolves and then becomes small. Becomes small, becomes big. Husband and wife, one must be becoming smaller, one must be becoming bigger. All right, let's continue. I don't know what is happening in your family. If your father is becoming small or your mother is becoming small, then one must be oxidizing agent, another one must be a reducing agent. All right. Maybe you are the one, you kids, who are making them to be oxidized. Or to be oxidized. Yeah, or to be reduced. Whatsoever, I don't know. All right. Net cell reaction. So now how do we form? You have reaction which is taking place here, reaction which is taking place here. So arrange them like this and then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid. I leave it. I go to copper ions this side. Yes. Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this side. I have zinc 2 ions. Do I have zinc 2 ions? No, I leave them. I have copper 2 solid. Copper solid. Do I have copper solid this side? No, so I leave them. So now I combine zinc plus copper 2. Zinc plus copper 2. This is a solid. This is aqueous. Always, whenever you have a charge, it is aqueous. You should just have to know that. Then the arrow, yes, and then I have zinc 2 aqueous plus copper solid. These ones, they cancel it. That's how you can write the full equation. Simple. Know what is an anode, what is a cathode, find the equation there. One must be reduced, one must be oxidized. Find the equation, write the equation down, then combine them. Simple. No stress. Then, salt bridge. Part of an electrochemical cell. It's usually a tube. It's usually a tube. It can be containing electrolyte, providing electrical contact between the two solutions. So we are saying that it's a part of electrochemical cell. Yes, usually it's a tube. It means that the chemicals are being put into the tube. Containing an electrical contact. It must be containing an electrolyte. It must be containing an electrolyte. It means that it can, the substances you have put there, it must be able to conduct electricity, and it should be able to release the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number one, to complete the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number two, it keeps the two electrolytes in the two half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these two must be neutralized. If they are not neutralized, then it means that the cells will be impaired. The cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell, so that the ions are neutralized, so that the cell can continue working or functioning normally. All right. Number three, this allows movement of ions between the two electrolytes. From the cathode cell and then the anode cell, the two must be able to communicate with one another, even if there is a distance, so the salt bridge connect them. Note, electrolyte in the salt bridge must contain ions, which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents, so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about it. Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel. So today we are looking at the standard electrode potential. The reactivity series is a list of substances which are arranged in order of their ability to act as reducing agents or oxidizing agents. So now we are going to look at which one is a strong reducing agent, which one is a weak reducing agent. And then if you know that, then you know how to interpret the reactivity series, then you will be able to know which one is going to be on the cathode, which one is going to be on the anode. So we are saying that a table of standard reduction potential can be used to, number one, we're going to look at that table and interpret it better. Number one, identifying the oxidizing and reducing agents. So we are able to know that this is a strong reducing agent, this is a strong oxidizing agent. Number two, writing a balanced redox reaction equation. You can be able to write this, predict whether the reaction is a redox, yes, is taking place spontaneously or not. So you can predict whether this redox reaction is spontaneous or it's not spontaneous. It can continue without an external battery. It can continue without an external source, power source, or it can't continue without an external power source. That's the meaning of spontaneous. And then you're saying that you can calculate the EMF, electromotive force, that is EMF, of this cell. So basically, this is the formula you are going to be using. This is the formula you're going to be using. Electrode potential of the cell is equal to electrode potential of the cathode. Remember, the anode is the negative terminal. So the positive terminal minus the negative terminal. So we need to know which one is supposed to be at the cathode and which one is supposed to be at the anode. Or you can use this equation. The electrode potential of a cell is equal to electrode potential of the oxidizing agent minus electrode potential of reducing agent. So you can use this, and then this is the formula you're going to be using so that we can calculate. But the problem is, how do we get this and how do we get this? So we need to understand how do we get this figure to write the electrode potential of that cell. Standard hydrogen potential. Let's look at standard hydrogen potential. Why do we start with the standard hydrogen potential? Because hydrogen is regarded to be the benchmark, is the one which we compare to. We compare to hydrogen. Whatever we do, we compare it to hydrogen. So it's the standard. Above it, then it means that the cell can continue. Below it, it means that the cell cannot continue. So we are saying that hydrogen gas, or what you call the hydrozonium ion, electrode has been chosen to be a standard half cell. So we are saying that it's regarded as the standard half cell. We compare to hydrogen. Basically, what happens is, if you look at this, you have hydrochloric acid. The reason why you have hydrochloric acid is just to increase the conductivity. Then you have platinum. Platinum or electrode has been coated with platinum. Yes. Why do we put a platinum here? Why? Because hydrogen is a gas. So we need something where hydrogen is supposed to go to so that it can react. So this platinum is just used so that it provides a surface area for this hydrogen to react. This, you have hydrochloric acid. The reason why you have hydrochloric acid is just to increase the conductivity. Then you have platinum. Platinum or electrode has been coated with platinum. Yes. Why do we put a platinum here? Why? Because hydrogen is a gas. So we need something where hydrogen is supposed to go to so that it can react. So this platinum is just used so that it provides a surface area for this hydrogen to react. So it comes like this to platinum. When it reaches platinum, then it can react from here. So the reason why this one is there is just to increase the surface area or to give the ground for hydrogen to react. So we are saying that the standard hydrogen electrode is a redox reaction. It means that it can have oxidation and reduction, which form a basis of the thermodynamics scale of oxidation reduction potential. So it means that whatever we are going to be doing, we are going to be relating it to hydrogen. So we regard this one to be 0, 0. You start from 0, 0. When you are numbering or you are counting, you start from 0. 1, 2, 3, 4 until whatever you want to reach. Or you start from 0 and then you go to negative. Negative 1, negative 2, negative 3. So in this case, hydrogen is the standard where we are supposed to start from. Oh, here is the standard electrode potential. You need to know. You see, hydrogen is here in the middle. Yes. Above it, it means that this one is more reactive than hydrogen. Below it, it means that it is less reactive than hydrogen. So if it is above it, yes, if it is more reactive, then it means that these ones are going to be anodes to produce electrons, whereby hydrogen is going to receive them. Below them, below hydrogen, it means that these ones are less reactive. Then it shows that hydrogen is going to be at the anode, which means that hydrogen is going to be the negative terminal. So hydrogen will be dissolving to produce electrons which are going to be accepted by this. Now, look at this. If you are comparing two of them, for example, calcium and the copper, yes? Calcium is at a top level, while copper at a lower level. The one which is at a top level is supposed to be the anode. You must know that. It's supposed to be the anode. And then the one which is at lower level, is supposed to be the cathode. Remember, anode is the negative, and then the cathode is the positive. So the anode will dissolve to give electrons, and then which are being accepted by the cathode. So we shall say that the anode is what is oxidized. Therefore, it's a strong reducing agent. So that's why you see that as you go up, the reducing agent increases the strength. So as you go up, it becomes more strong. It becomes more reactive. It becomes more easily release the electrons. It can easily release the what? The electrons. Or electrons can be easily released. So it becomes a strong reducing agent. A strong reducing agent is supposed to be at the anode, yes? And then a weak reducing agent is supposed to be at the cathode. Why? Because this one is positive, this one is negative. So this one gives electrons to this. So now we are going to compare copper, yes, copper with hydrogen. So I will come here and say, hydrogen is here, yes? Copper, you have copper 2 to copper 1. It's not yet fully reduced. The one which is fully reduced is this one. So I have hydrogen and the copper. So which one is going to be at the cathode? Which one is going to be at the anode? We said that the one which is on top is supposed to be the anode. The one which is down is supposed to be the what? The cathode. So now I will say that hydrogen is going to be at the anode. So it's going to become the negative electrode, the negative electrode. And then copper is going to be at the cathode, the positive electrode. What about when I compare hydrogen and zinc? We have seen here that now here hydrogen is at the anode and the copper is at the cathode. What about hydrogen and zinc? You have zinc here and then you have hydrogen here. So it means that zinc is more reactive than hydrogen. Therefore, zinc is going to be at the anode, while hydrogen is going to be at the cathode. You see? So the one which is more reactive must be at the anode. The one which is less reactive must be at the cathode. The one which is on top, even if you don't read this, it's fine. The one which is on top is more reactive. Is easy in releasing electrons. You must have that concept. The one which is on top is easy to release electrons. So this one, it easily releases electrons. You understand? So it becomes the anode. And then the one which is below hydrogen, it becomes the cathode. It means that it's easy in accepting the what? Electrons. So let's go back to determining the standard electrode potential of copper half cell. Here you have the copper half cell. You have hydrogen this side, you have copper this side. We don't know which one is the cathode, we don't know which one is the anode. Now, how do I identify that this is the cathode, this is the anode? This is what you are supposed to do. Hydrogen and the copper. Hydrogen is more reactive than copper. So what does it mean? Hydrogen must be at the anode. Copper must be at the cathode. I go back. I have to find out. So we say that hydrogen is more reactive than copper. So this one becomes my cathode. Why? Because hydrogen is more reactive than copper. And then the one which is more reactive, the one which is above the reactivity series is supposed to be the anode. The one which is below the reactivity series is supposed to be the cathode. This is a negative terminal. This is a positive terminal. Negative terminal give out electrons. Positive terminal receive the electrons. You see? Now I'm going to go to identify which one is a positive, which one is the cathode, which is an anode. Now I have to know which reaction is happening on each. If this is negative terminal, yes, and it gives out electron, so I have to show a reaction here where the electrons are forming. It means that when hydrogen comes, yes, it's gonna react here to form hydrogen ions plus electrons. Yes, these electrons will move to the cathode, where copper is going to receive these electrons, so copper 2 ions, plus these 2 electrons to form copper solid. You see here, hydrogen comes in, yes, it forms hydrogen, hydrogen gas, is supposed to have a gas here, and then hydrogen ions, so it dissolves here, it reacts here at the platinum, and then it forms hydrogen ions, which is aqueous, plus 2 electrons. These 2 electrons, they move. When they move, they come to copper. Here you have copper copper solution. Yes, these copper 2 ions, they accept these electrons, yes, and then forms copper solid. So what is happening? But all this, you have identified it from this. You have identified this from this point, that hydrogen is above, copper is below. So hydrogen becomes the anode, while copper becomes the cathode. How do you write the full reaction equation? Hydrogen, that's before the arrow, plus copper 2 ions, giving me after the arrow 2 hydrogen ions plus copper solid. This is what I'm trying to say. Hydrogen gas, yes, plus copper 2 ions, which is here, giving me hydrogen, 2 hydrogen ions, which is this, plus copper solid. That's it. So before the arrow and then after the arrow. Before the arrow and after the arrow. So it's supposed to be like that. So, and then you cancel out what is similar. Electrons this side, I have electrons this side, I have electrons this side. So I cancel them out. So how do I write the cell notation? How do I write the cell notation? This is the cell, net cell reaction. This is the half cell reaction. And then this is the half cell reaction for copper. This is the full when I combine them. What about the cell notation? How do I represent this in the form of equation? So I will start with this. Yes. So I will say that I have with the anode. Yes, when you write the cell notation. I have hydrogen. Yes, the hydrogen. This hydrogen goes to platinum. So I have hydrogen gas, comma, it goes to platinum because this platinum shows that this is just an electrode. But if, okay, I'll explain it. It is showing just an electrode. So this hydrogen, the hydrogen gas, comes to platinum. Yes. When it comes to platinum, it reacts, you see, it reacts to form hydrogen ions. So it reacts to form hydrogen ions. Are you seeing? Which is aqueous. Then I've completed this one. But in between here, we have a salt bridge. Remember I said that the salt bridge is indicated by a double forward slash. So forward slash, then I go to copper. So when these electrons come, they will find the solution here of copper. Yes. So this copper two ions, yes, which is aqueous, yes, it will give me copper solid, which is this. So basically, that's how you're supposed to write it. In this cell notation, we don't balance the equation. You don't put the two. No, you just have to write what is really happening. But in the net cell reaction, we balance. It's supposed to be balanced. That's why you have here only hydrogen ion, and yet here you have two hydrogen ions. Let's look at another example. So we have said that this is zinc. The reaction is talking about zinc, measuring electrode potential of zinc to iron, zinc to iron in the system. All right, what happens? So now I have to know, this side I have hydrogen, this side I have what? I have zinc. Now I don't know which one is the, don't cram, I don't know which one is a cathode, which one is anode. So we have to go back to the reactivity series, and then we see zinc versus hydrogen. Zinc is here, yes, versus hydrogen. Hydrogen is here, yes. So it means that zinc is more reactive than hydrogen. So it means that zinc is going to be the anode, while hydrogen is going to be the cathode. Let's go back. So now if you are saying that now we have understood that zinc is the anode, is the negative, it's more reactive anode. Which one is on top? Anode. And then the one which is at below becomes the cathode. So this one becomes negative. So this one becomes positive. This one becomes negative. So this is anode, this is cathode. This is anode, this is cathode. It means that this one gives electrons to this. So let's interpret. It shows that zinc is going to react, yes, to form zinc ions. Then these two electrons are going to move, yes, to go to hydrogen electrode. You see? Now, what happens? The hydrogen ions, which are in the solution here, yes, are going to accept the two electrons from the zinc to form hydrogen gas. That's how it's supposed to be. We find oxidation. This one is oxidized from zinc, which is 0, to zinc to iron. It's oxidized. So it releases electrons. Electrons will travel to this. Now, this one is what? Is now negative. It shows that now it can continue on its own. Yes. This, yes, it means that it's a strong, this one, it shows that is a strong reducing agent. If it is negative, it shows that is a strong reducing agent. If it is positive, it shows that it's a weak reducing agent. So basically, that's it. So how do we write this full cell equation or net cell reaction? So you have, you're supposed to start with the anode, then you end with the cathode. In this case, this is the anode, and then this is the cathode. So let's see. Zinc, yes, which is zinc, this one, for the arrow, plus 2 electrons, plus 2 hydrogen ions, which is this. Electrons have cancelled, giving me hydrogen after the arrow, plus zinc 2, which is after the arrow. That's how you're supposed to write. Cell notation. Remember, you start with the anode. So zinc, which is a solid, yes, is oxidized. Yes, is oxidized, or it dissolves. This electrode dissolves to give zinc to ions. So zinc, which is a solid, is oxidized to zinc to ions. Yes. So now I don't have anything in this side. Then I'm separating this by a short bridge. Slash, yes, when it goes here, these electrons, they will find the ions here, or hydrogen.